Hi everyone. Today we're going to start our last unit of the year, which is on stoichiometry. So this is a pretty weird word, so let's talk about what it means. So it comes from two Greek root words. The first is stoichion, which means element, and then the second is metron, which means measure. So in this unit, we're going to talk about how to measure elements, and particularly we're going to talk about how to measure the amounts of elements in a chemical reaction. So when we say stoichiometry, we're talking about the study of the quantitative relationships between the amounts of reactants and the amounts of products formed by a chemical reaction. So let's take a look at a pretty common chemical reaction. So this is the reaction of baking soda and vinegar. So in the bottle here is vinegar, and then in the balloon there's baking soda. And when the baking soda is tipped over into the bottle, the chemical reaction occurs, a gas is formed, and the balloon blows up. Right? And so when we say the quantitative relationships, we're talking about how are the amounts of reactants and the amounts of products related. Right? So you can see here, as you might imagine, right, the more vinegar and the more baking soda you have in your bottle, the more gas is going to be formed, the more of your product is going to be formed, and therefore the bigger your balloon's going to get. So when we talk about stoichiometry, we're talking about how to relate the amounts of everything in a chemical reaction. Before we talk about molecules and chemical reactions, first we're going to talk about grilled cheese. So thinking about making a grilled cheese sandwich, you have to know a couple of things. So you have to know what are all the ingredients, and then you have to know how many of everything that you need. So to make a grilled cheese, you're going to need bread, and you're going to need cheese, and you're going to put those together to make a sandwich. So you've got your ingredients and you've got your result, and then we have to think about how many of everything that we need. So to make one grilled cheese sandwich, you're going to need 2 slices of bread, 1 slice of cheese, and you'll make 1 sandwich. All right, so this is like our balanced chemical equation. So we've got our coefficient here of 2. Remember that if you don't see a coefficient, it means it's a coefficient of 1. And then over here, we're making 1 sandwich. So thinking about this equation or this reaction here of making our grilled cheese, I'm really hungry, right? So it's about lunchtime, and let's say I want to make 7 grilled cheese sandwiches. So the question here is, how many slices of bread am I going to need to make 7 grilled cheese sandwiches? Now I know you can probably figure this out in your head, but we're going to use dimensional analysis to solve this problem, and then we're going to apply it to a chemical reaction. All right, so first thing you want to do is set up your dimensional analysis grid, and then put the information that you know in the top left-hand corner. So this problem tells us that we're making 7 sandwiches, so I'm going to put that in the top left corner. Underneath that, you want to put a 1 as a reminder to not put anything else in that box. And then in our next set of boxes, we want to set up a conversion factor that will allow us to cancel out the unit of sandwiches and get us to the unit of slices of bread, since that's what's of interest here. Okay, and so we know that for every 1 sandwich, we're going to need 2 slices of bread. So I put sandwich on the bottom so that I can cancel out my units of sandwiches, leaving me with units of slices of bread. Now remember that you want to multiply across the top and divide by the bottom. So here we would get that we need 14 slices of bread to make 7 grilled cheese sandwiches. So let's think about how that applies to a chemical reaction. So this is the synthesis of ammonia from nitrogen and hydrogen. Remember that nitrogen and hydrogen are both diatomic molecules, which is why you see this little subscript 2 here. So the first thing that we always need to do anytime we've got a chemical equation is we need to balance it. So one thing we might notice is that we've got 2 nitrogens on the left, so we need 2 nitrogens on the right to balance that. So I'm going to put a 2 in front of NH3. That means that now I have 2 times 3, or 6 hydrogens on the right side of the equation. And so I want 6 hydrogens on the left side of my equation. So I'm going to put a coefficient of 3 in front of the H2. So now that I've got my balanced equation, let's think a little bit more about what this means. All right, so what this is telling us is that if we take 1 molecule of nitrogen and we add 3 molecules of hydrogen, we can form 2 molecules of ammonia, NH3. Right? So that's 1 molecule of nitrogen, 3 molecules of hydrogen, making 2 molecules of NH3. Now, what if I had 10 molecules of nitrogen? Right? So if I had 10 molecules of nitrogen, that would react with 30 molecules of hydrogen to produce 20 molecules of ammonia, right? So no matter how much I start with, that ratio is going to stay the same, 1 to 3 to 2. All right, now remember that atoms are so small that we really can't count out 1 molecule or even 10 molecules or 100 or 1,000, right? We need to count out a lot of molecules at one time just so that they're big enough for us to actually weigh and measure, right? And so it turns out that if we scale this all the way up and I had 6 times 10 to the 23rd molecules of nitrogen, right, that would be 1 mole of nitrogen. That 1 mole of nitrogen would react with 3 moles of hydrogen to produce 2 moles of NH3. All right, and so we can use that ratio, 1 to 3 to 2, we can call that a mole ratio. And so a mole ratio is the ratio between the amounts in moles of any two compounds involved in a chemical reaction. So when we do stoichiometry, we're going to use mole ratios as conversion factors. So for example, in this reaction, there's a mole ratio of 1 mole of nitrogen to 3 moles of hydrogen. There's also a ratio of 3 moles of hydrogen to 2 moles of ammonia. And there's also a ratio of 1 mole of nitrogen to 2 moles of ammonia. Using this information, we can answer questions like this. So how many moles of nitrogen are needed to form 10 moles of ammonia? Right? So that mole ratio is going to help us to answer this question. We're going to use dimensional analysis just like we did with the grilled cheese sandwiches. Right, so first we set up our grid, and then we want to put the information that we know in the top left-hand corner. So the number that we know is 10 moles of ammonia, right? So we start with that. Remember to put a 1 underneath that box so you don't put anything else in there accidentally. And then in our next set of boxes, we want to set up a conversion factor that will allow us to convert from moles of ammonia to moles of nitrogen. So I want to cancel out moles of ammonia. So I want to put that on the bottom, and I want to put a 2 because of this coefficient 2 in the balanced equation. All right, now I want to look at the mole ratio of ammonia to nitrogen, and I can see here that nitrogen has a coefficient of 1. So on top, I'm going to put 1 mole of nitrogen. All right, so again, these numbers come from the coefficients in the balanced equation. And I want to set it up so that I'm canceling out the unit that I don't want and introducing the unit that I do want. All right, so I'm going to cancel out moles of ammonia, leaving me with moles of nitrogen. Now again, you want to multiply across the top and divide by the bottom. And when you do that, you get 5 moles of nitrogen. Notice here that I've got 1 significant figure in my question. So this number 10 has 1 sig fig. And in my answer, I also have 1 sig fig. Let's try another example together. So let's say I have this question. How many moles of ammonia can be formed from 0.37 moles of hydrogen? All right, so this question here, again, I want to convert from moles of hydrogen to moles of ammonia, and I can use a dimensional analysis to do this. So I set up my dimensional analysis grid, and the information that I know this time is 0.37 moles of hydrogen. So I'm going to put that in my top left box, and I'm going to put a 1 underneath it. Now, in my next set of boxes, I want to cancel out moles of hydrogen and introduce moles of ammonia. So I'm going to use my coefficients in my balanced equation, again, as a way to set up that mole ratio. So I know that the ratio is 3 moles of hydrogen to 2 moles of ammonia. So I'm going to put 3 moles of hydrogen on the bottom to cancel out moles of hydrogen. And I'm going to put 2 moles of ammonia on the top to introduce moles of ammonia here. Now, moles of hydrogen and moles of hydrogen will cancel, leaving me with the unit that I want. And now I can multiply across. So 0.37 times 2 divided by 3. And that's going to give me 0.25 moles of ammonia. And again, I've got 2 sig figs in my question here. So I want 2 sig figs in my answer. Now I want you to practice some of these mole-to-mole conversion problems. So I've got a set of practice problems attached here. Please show your work using dimensional analysis. And then tomorrow we're going to talk about how to incorporate mass into these stoichiometry problems.